In this video, we're going to cover section 6.5, Properties of Special Parallelograms. So previously, everything we covered has been about parallelograms, or the last two sections have been about parallelograms. Remember, the defining characteristic of parallelograms is two sets of parallel sides, and we looked at the relationship between these. Opposite angles are congruent, adjacent angles are supplementary, opposite sides are congruent, diagonals bisect each other. Now what we're going to do is look at a subset, three different parallelograms that are special. So here we have a rhombus. This is the definition of a rhombus. All four sides of a rhombus are congruent. Okay, so if you have a quadrilateral with four congruent sides, then it is a rhombus. Now please note that a rhombus is a special type of parallelogram because opposite angles are congruent. Okay, now if we look at this, all the sides are congruent. We're looking at the angles inside, angles 1, 2, 3, 4. And the other thing to note about this is, because of my inclusive definition, a type of a kite. So we already know, because we have two pairs of adjacent congruent sides, that's a kite, we know that the diagonals have to be congruent. Sorry, diagonals have to be perpendicular, so these angles are all 90-degree angles. So in a rhombus, the angles inside have to be 90-degree angles. Now the other thing to note, look at this. Here we have two isosceles triangles that are congruent. Okay, we know that opposite angles are congruent because of the fact that it's a parallelogram. And so all four of these angles are congruent, and they're congruent to each other because they're base angles. So let's put that in a theorem. So if a parallelogram is a rhombus, then its diagonals are perpendicular bisectors of each other. So not only are they perpendicular, but they cut each other in half. Okay, and that's because it's a parallelogram. If it's a parallelogram, then each diagonal bisects a pair of opposite angles. So any diagonal in a rhombus cuts the angles that it goes through. It bisects it. So example 2, find the lengths and angle measures in a rhombus. What is ADE? And let's just go through and find all of these. So this is a 90-degree angle. These are all 90-degree angles. Now this is also a 53-degree angle. So what we're going to do now is we are going to find, oh, well, this is a 53-degree angle because the diagonal bisects the other angles. So I just have to figure out what this is. And I'm just going to go 53 plus 90, subtract from 180, that's 37 degrees. So this is also 37, 37, 37. And that just by knowing it's a rhombus and having one angle, I could find all of the remaining angles. Okay, so this says, what is GH? So GH is this length here. It doesn't tell us any information about that other than because it's a rhombus, we know it's the same as that. HJ, and HJ has X in it, so we're going to use the other expressions to find X. And we know that in a rhombus, diagonals bisect each other. That's true for parallelograms, and a rhombus is a parallelogram, and these are perpendicular bisectors. So we're going to solve this for X. We added 7 there to get the 10. So X equals 5. And then we take this 5 and we plug it in here. So 3 times 5 plus 1 is 16. That means GH has a length of 16 units. Okay, so those were a couple relationships about the rhombus. Remember that a rhombus, by definition, all sides are congruent. Quadrilateral with all four sides congruent. And then we deal with the diagonals are perpendicular bisectors of each other, and each diagonal bisects the opposite angles. So now let's look at a rectangle. If a parallel is a rectangle, then its diagonals are congruent. Now we need the defining characteristic of a rectangle. So it is a parallelogram with 4 right angles. That's the defining characteristic of a rectangle. Okay, so if we have these 4 right angles, then the diagonals are congruent. So let's write a proof of this. So given that we have a rectangle, meaning that we have 4 right angles, we're going to prove that PR is congruent to QS. So we have our statement, and we have our reason. So PQRS is a rectangle. This is given, of course. Okay. Now what we're going to do is I'm going to say that PS is congruent to QR. And I'm going to reference the theorem that tells us that. Now, a rectangle is a parallelogram, and so all of the theorems regarding parallelograms applies to rectangles as well. So what I'm going to do is I'm going to look at my reference sheet here. It has my theorems on it, and this is going to be, so I want the theorem that says in a parallelogram opposite sides are congruent. So that's theorem 6-7. Okay, so we now know this is equal to this. Now I'm going to say that SR is congruent to SR, and that is the reflexive property of congruence. Now we have 2 sides being congruent. We need the angle in between them. So I'm going to, for 4, I'm going to say angle S is congruent to angle R. I'm going to use the definition of a rectangle. And now I have enough to say that triangle PSR is congruent to triangle QRS by side, angle, side. And so if the triangles are congruent, then PR is congruent to QS by CPCTC. Example 4. Paul is training his horse to run the course at a pace of 4 meters per second or faster. Paul rides his horse from D to C to E to B in 1 minute, 30 seconds. The figure ABCD is a rectangle. Did he make his goal? So again, his goal is to go 4 meters per second or faster. So we need to figure out how many meters he went. So from D to C was 192, and then from C to E and E to B, now these two are the same length, okay, because this is a parallelogram. We know that the diagonals are cut in half, but because it's a rectangle, the diagonals are congruent. So it would be the same as if instead of going E to B, he went E to A. Now, it takes a little bit to turn probably, but that's the goal, or that's the length. And so what we're going to do is we're going to find the length of one diagonal by using the Pythagorean theorem. 80 squared plus 192 squared equals dB squared. And if we do that, we get 43,264 equals dB squared. So we square root both sides and we get 208. So now we have 192, that's this length here, 192 plus 208 is 400, and we're going to divide that by the number of seconds. 1 minute 30, so that's 90 seconds, which is approximately 4.4 meters per second. So that is faster than 4 meters per second. So he did make his goal. All right, example 5, diagonals and angle measures of a square. Now let's just define square real quick. So it's a parallelogram with 90-degree angles and 4 congruent sides. So a square is the mixture or combination of a rhombus and a rectangle. Okay, so that's the definition of a square. So figure WXYZ is a square if WY plus XZ equals 92. What's the area of WPZ? So WY plus XZ is 92. That means one of these lengths would be half of that, which should give us about 46. Okay, now because this is a right angle here, let me change the color so you can see that. Because that's a right angle, this would be a 23 by 23 right triangle. And so we should just go 1/2 base times height. So 1/2 times the base of that right triangle times the height of that right triangle gives us 264.5 units squared. And that is the video for 6.5. Thank you for watching.